Hey everybody, I want to give y'all a little update. Look what I got from China. Not General Chow's cat, but another box with a turbine. So I want you guys to take a look here, and I'm going to show y'all some important stuff. Stick with me, and I want you to share this video. Down below the video will be everything that we're using, and a few other items. Look below it, down at the upload date, you're going to see a list of parts, where this turbine comes from, where some of the parts that you can do this with come from, another manufacturer that makes the same controller, and you're going to see this in a minute, and pardon my dirty hands, been building. We're going to be showing you the standards of a wind turbine. Here is the wind turbine. Now in my case, I'm using 12-volt systems for my wind turbines. We just got another one in, and we're going to show you what this little one has in the box, and then we're going to show you a test on it and a really neat, don't go away, OPC, Olympic Power Controls box that I build for my customers, people I do installs for. This is important. Now, generally you have a wind turbine, and unless it is, they're going to claim 1,800, 2,000 watts from something probably no bigger than my hand. It's not possible. Just get in your head now, and if it doesn't have 4.5 foot blades, it'll never cover 300 watts. If it doesn't have 7-foot blades, it'll never hit 1,000 watts unless it's in a windstorm. And if it don't have 9-foot blades, it is never going to see 2,000 watts unless it's in a hurricane. So just get that in your head now. That's important information. What we're working with is we're working with a wind turbine. The way that these work is you have the turbine, and then they have 3-phase wiring inside them, the stator that's inside them, and a rotor that's inside. The rotor is permanent magnets. It's spinning inside of a stator. It's not like a car alternator, but you can modify a car alternator, and I'll show you one here in just a second, to make one yourself. This is the turbine. Your 3 wires will go down, 3 wires will go down. That's 3-phase, 3-wire, and it'll reach a rectifier. And I'll show you all this. A rectifier then converts it by fielding it to one side. Now, it is a chop. It is a chop. And your battery, unless it's a very small battery, is not going to be affected by it. In fact, if you have solar power now, and you want to preserve your batteries for a very long time, you want them to last for years, a small wind turbine like this one is the best option that you can do. The reason is because it is a slight pulse as that wave goes through there. So let me explain this and how it works, and you could probably go look up other videos on rectifiers. But you start out with a sine wave. That's an overlayered sine wave. Now that's 3 phases is what you're working with. But what you end up with is you end up with a DC sided only. So it's pulses, and the battery has no problem handling that because it's on, basically on and off. That's how it works. So your power is going to go through here and be rectified into DC voltage. The DC voltage is they're going to be above the battery. So if your battery is 12 volts or 48 or whatever, let's just call this one 12 volts. So if your battery is 12 volts, then you're going to start charging at above the static level. And the static level of a 12-volt battery is 12.8, okay? That is what they sit at normally, is 12.8. So once your turbine speeds up enough to reach 12.8, everything above that is charging. Now you have an inverter over here. Say you have an inverter hooked to your battery, and your inverter has a 15-volt over voltage, so you're going to have to do something to prevent this from hitting that. That's where this comes into play. Diversion, control, and load. Load is determined as resistors, and diversion is by a board that's going to control relays. And please do not buy a big one with big old goofy solenoid on it and big terminals and all that. Don't do it. Don't do it. I'm going to show you why. So let's get over here right quick. I'm going to do a real brief on one of the control boxes, and we're going to open this thing up. Sitting over here is an Olympic Power Controls box. I build these for customers. For what we're doing right now, I'm doing a test where I'm going to show you there's a resistor. Now this one's a 300 watt turbine that we're going to be looking at, and it's a real 300 watt turbine. It's not one of these Mars Rock, whatever things. It's the one that comes with a PMA that's that big, not this big. Big damn difference. The second thing is in the PMA, it doesn't have a screw in the middle and a metal band with a big gap missing on the magnets. It is all magnets, and they're slightly angled like a thermodyne. If you guys want to build a kit of your own, nothing freaking beats these. This is a thermodyne. I'm going to show you deep in here. You look in there and you see that. This is made like you have no freaking clue. Down below, I'll put a link to this guy's stuff. I buy a lot from him. He's pretty quick to ship. You get it pretty quick. You do have to request the hub adapter, and it comes with a nut, but make sure you request a hub adapter, and then you can, with blades that you can get. Now those are big blades up there. Those are his, and they're kick-ass. They're called KT blades. If you order the whole turbine kit, then what you're going to be able to do is you'll be able to go and modify it the way I'll show you if you watch my videos, how to make it with a nice yaw bearing and slip ring. Beautiful. You can go back and look at some of my old videos. A lot of videos on my channel about wind turbines. So, and solar and trailers, and you know it. This is a rectifier. This is a shunt. This is an SSR. This here is a control board, and if you look down there, that is me, Olympic Power Controls. I don't know if you can read that very well. And it is a manufactured by Mason Company. So you're going to get a link to where you can either get one that's made for me, because he has a stockpile of them also, as well as his own, and they'll be a little different. They have a pin selector in here, so you can set it for equalized load. You only got, well, say you got one wind turbine. Set it for equalized, let it run up to 14.7. Works great. However, we're going to show you this one in action, and then we'll pull the other PMA from over there, and we're going to hook it up, and we're going to show you with a load, with a battery, output, everything that's going to go on it. We've even got a souped up drill, 20 volts into an 18 to get it sped up real nice. And we've done this a few times and tried it. I've got my settings already set, is when it'll kick this relay on. The reason you want a solid state relay is because they hang up in the default off, disconnect. So instead of having the big, huge monster metal relay that'll lock into place or fuse and kill your batteries, and they'll literally set your batteries on fire, you have this that is made to just lose itself, and it won't maintain a connection, because this is an optical connection in here. You know how you have a porch light that comes on at dark? Well, what happens is when this receives a circuit feed and that little light comes on, it actually shines a light inside here for an SSR. Now, it's a little less, you know, this is just an odd description. It's a light activated switch. So you have like your porch light, you know, that comes on at night, on at day, or on at night, however you want to set them up. This is about the same thing. It is a relay based on MOSFET switches and based on a light CDS cell. You know, that's how it works. So this one's a DC to DC. This here will put out a signal, and as soon as the voltage drops below, which we've only got one resistor, so on this thing is going to hit 150 watts before you get a chance to let off of it. So we only have one resistor, but I'm going to show you how it works and how well it works. And we're working with a 100 amp meter right there, volt and amp, and a 100 amp shunt, and the OPC board, a fan, a heat sensor right here, a bimetal switch that as soon as this thing gets warm, and it'll get it warm on this side first, and as soon as it gets warm, it kicks the fan on, and the fan will run the whole time until the wind stops, or the wind is so slow that it's not producing enough heat. So it has to get up to basically 114 degrees, and it'll kick the fan on and evacuate. So you'll see how I put my intakes here and my intake here. My intake here is to prevent heat from this big heat sink. You see it down in there? If I can get a better picture there. Is to keep the heat from this heat sink from affecting my board. Works good, been building them for 5 years, no fails. All right, so now we're gonna get dicey out of here, and we're gonna show you the Chinese wonder. That's coming up. Let's take a look. All right, guys, now I've got my two helpers and we're going to open up the turbine. So it's fresh. It just got here. Brand new in the box. It's an S model. You'll see that. Now that is one of that's the model it's called is an S model. And we'll go ahead and get this thing open right quick and we're going to lay it out for you.
Alright guys, as you can see, it comes with the user's manual and it's the Model S. Pretty good. It's got all the information in it, as you can see. And then it comes with the installation guide. And if you don't understand English, you can always read it in Spanish.
Well, there you go, guys. My daughter kind of figured the world out already, hasn't she? So, what it comes with in here, and he's going to pull all these parts out, and she's going to lay them out for us. 1, 2, 3 blades. So this is a 3-bladed model. And how long is our blades, please? So the blade length here,
About 25.5 inches.
About 25.5 inches. So that is about, when you add the hub, about a 54-inch circumference. Not too bad. So roughly 4.5 feet. And it has in here, what else do we got in here? It comes with the basic controller, I believe. That looks like the basic controller in here. So we want to get that one opened up. Yeah, so it's the standard 03 style controller. So generally 3-phase 12-volt controller. It's a 300 watt. It has a breaking voltage of 15 volts and a recover voltage of 13.5. So it'll break down until it hits 13.5. Let me get over there so you can see that better. And it has a very low milliamp consumption ratio, and this is weatherproof, so you can put this outside. Don't put it directly in the weather. All right, now we have the wind turbine body and PMA in here. We'll go ahead and get it. Let's get there's a hub cover, nose cone. We have the flange. Now this is the S model flange. They have an S, they have an M, and then they have one that's for the 1,000 watt. So this is the smaller. You can weld this to 1.5-inch pipe, or look below the video. You're going to see where I will show you a special tubular fitting that just clamps onto your pipe and bolts in to this. And you have the hub. All right, so we've got the standard 3-blade hub. And you'll notice that the hub has got the dimple design, or the special teardrop design, so that it locks into the blades, centers it very well. Very easy flange to work with. And the wires, although this is 14 gauge, so when you're talking 300 watts, you're not talking about a lot. And the PMA in these things is about that big, so it's not as honking big as the one that's in the ones on the roof of my shop. You can go back and look at the video there and see, my previous videos about that turbine. And we're going to run this one up into a test. You will notice that you have free play in this shaft. And the reason that you have free play, you could actually push on it and it'll flex a little bit, is because you have suspension, magnetic suspension in the center with your core that the magnets are on. You have suspension, so you might have a little float in this. When you put your hub on, it's going to seat. You see that part right there? It's going to seat right up against that part of your bearing. Now, we prefer these. These come from Green Energy over in China, and we prefer buying them from AliExpress, because the one thing that you're guaranteed is that if you get a bad eBay or Amazon seller, they're just going to change their freaking name and disappear. Now, one of the problems that a lot of people ran across is you see this poly seal that's inside this nut right here. That poly seal, I'll show you here what we do to solve that little problem. It makes driving this on a miserable feat, and you feel like you've never got it far enough on there. So if you'll look in here, we're going to take a regular blade, and we're going to go ahead and we're just going to take and kind of take out some of that plastic, you see, because it seems like the plastic is just a little too much. And trust me, you ain't got to worry. This will always remain tight because if it is spinning in clockwise, the tightening, it's not going to come loose. You could basically just put a regular nut on here and it's not going to come loose. So this has been a problem with a lot of turbines. So you just want to get the tip of your razor down in there. Watch the fingers, don't cut yourself. And you're going to kind of chew some of that away a little bit. Now, the next step is you're going to put a little drop of oil on this, and then you'll shoot it on. You will put it on, and when you get your hub on there, and you're going to put the drill in reverse, and it's going to put it on there. So put your drill or impact. I use an impact, but right now I'm just showing you with a drill. You're going to put that in reverse while you have your hub and your blades on here. And you'll see that it starts to go on, and it'll continue to spin until it pulls itself on. So once you've done that, you're good to go. Put it in forward, and you can, because what you're doing is you're just spinning the shaft with the Allen wrench here. So what we're going to do is we're going to run over here right quick, and we're going to hook up right here, and I'm going to show you how. And you can do this with any good quality controller, but I'm going to show you how. So you'll look at the voltage here, and you're going to watch for when that little light comes on, and it's going to divert. So this load here, this is your diversion load. This is your power to your batteries, going back to your batteries. When you get one of these type of controllers, you're going to always hook up battery first to power circuitry, and then your turbine, and then your diversion load. Make sure that you have that. So you'll see I have 3 wires coming in here, just a standard 14 gauge cord going to this big Thermodyne. Now this one will kick the hell out of you, but I'm going to run it up, and then I'll close this door and run it up again and show you the amperage. But you'll get to see here that this is going to show you the voltage of when it starts to divert. So right now we're at 12.68. That's pretty much static. This meter will be about a 1/10 off because it's load in here, and we were running this a minute ago, so the fan is on. The rectifier is still warm, but we're going to go ahead and run it now. And watch for the lights, and you'll see all the service and activity lights come on, and then that. So it got almost impossible to turn at that point. Now, it ran up to about 14.5 volts, kicked on this, and got that up there very warm. So there's just a 100 watt is all we have on this just for the test. You saw how this worked. You can also hold this button down for 3 seconds, and it will cycle. And it'll go through the cycle, and it'll also do a test cycle. Now, once again, with this closed, you're going to watch up here, and we're going to show you the amperage of what this PMA, this is a Thermodyne, puts out, and then we'll quickly swap this out to the little one that's back here. As you can see, as volts go up, amps will go down. Now, there's the 14.4. As you've seen it flash to, that was the resistive load going to the battery. And if you would have seen this one down here, it hit about 14.5 before it really cut that drill back with that extra load up here. All right, now we're going to pull this all loose, and we're going to get this little turbine over here, and we're going to hook it up the same way, and you'll get to see what it gets to do, how it puts out power compared to a monster Thermodyne. Let's go. All right, now we have the small S model 300 watt turbine hooked up. And for you guys who don't understand how this works, this thing can turn back and forth. It has internal a slip ring. Look up here in the top of the video, right there. There'll be a link to where you can go and learn about slip rings. That'll also help you figure these out so you won't have to worry. And these slip rings that the manufacturer puts in these will easily handle 100 amps. They're not cheap, they're good quality. So we're going to go ahead and get this one here and run it up. So you'll see where our current status is. We're at 12.68 volts, that's the battery. And We are still running on the fan because it's still warm. Watch for these lights up here and watch for that to kick on. The wiring on it, as you can see there, is the same 14 gauge wires running up, and all you do is you hook these up any wire. It doesn't matter what you use, just a wire per leg coming from the turbine. So I'm going to hold on to this thing, and you'll get to watch the voltage jump up on it. And yes, we're going to show the amps, but it'll pull itself down as soon as that kicks on because it's extra load more than the battery. There, it got real hard to turn there. So at that point there, that kicked on. That's the battery being full, and it put a load against the turbine, slowing it down. So the turbine lost some of its speed, and that way in a bad windstorm, this controller prevents overcharge of your batteries. Now, we're going to go ahead and close this, and I'm going to give you an amp reading. So you'll see we're back down to 12.6. That's 1/10 off what this is, very common. You can adjust these to get them a little higher, but as long as that fan's running, it's pulling this down a little bit because it's wired in the same circuit. But watch for this amperage right here. And we're going to go ahead and take this thing and take the drill, and we're going to spin up this little turbine again to get you that report there. So the drill, luckily, because it has a lithium battery on it, wants to kick out once it gets too much of a load on it. And the too much of a load has nothing to do with the turbine, but it has everything to do with the fact that more load was put against the turbine, and that's the purpose of the braking resistors and the braking system, diversion system that's in these. So let's go back over here. As you've seen, that put out a hell of a lot of power. Now, this one is supposed to do that with 4.5-foot blades. This one is supposed to do it with 70-inch blades, roughly 6 feet. Back over here again, as you can see what we were working with the turbine, the 3 wires going into the rectifier, and then the power going from there to the battery. Now in my case, you've seen all that internally wired, but it's pretty much the same thing to wire a diversion controller's sensor wires to the battery. So you'll have the feed that comes from here to the diversion controller. Let's run back over there right quick. So your feed wires will go to here. Now mine, like I said, they're all internal, and then they'll come out and you'll pull power from the battery. You will put, if you wonder how do I wire this, it's simple. Right there, relay plus and negative right there, and there's your battery power. So you'll pull battery from, like I got it here, and you'll send power over to your relay. So this is a DC to DC, and then what I got here is I have a wire going from here, and it goes to the positive. That is the positive wire, and this is basically a return circuit. So it shows you a negative, but it's not a negative. It's just, this is just, they connect. So it's not a negative, but you'll add your wire coming from here going to the positive side, and your resistors don't care. There is no positive or negative on a resistor unless it is an adjustable, like a rheostat. Then you have a positive or a negative in those cases, most of the time, not always. So there you go, that's the basics. This little controller right here, I know people might ask me, can you build me one? I got a load of these to still do. This is my busy season. If I ever got a chance to get around to it, I'd put a bunch on eBay. But this takes about 8 hours to build, test, tune, set, and it has to be spec built for the person that it goes to. If you're in Colorado and you got 40-mile-an-hour winds, there's a certain setup I have to do for this. If you're living in Ohio and your winds are high sometimes and 8 to 10 miles per hour and you're going to average 10 to 15 amps at best, then you need a different controller. In fact, that's when this little controller here is perfect. It does work good. It works good for that basic need. If you're going to add a lot of solar to it and you're going to add a lot more turbines, 2 or 3 turbines, you better get a real controller that diverts. 1 turbine, not a big deal. 3 or 4, like this woman that's going to have these put up, big deal. So there you go, guys. Long video. Hate to do it to you, but I'm trying to get through everything to make it simple. I don't want this to be difficult for people. Be sure if you use 1.5-inch pipe, you can use 10 feet 1.5-inch pipe, and then you take 2-inch pipe and it'll slide down inside of it. Look at my other videos, I'll explain that. And you can drill it and put set screws in it, and you can actually use that as a telescopic to where you can put some type of a pegs in it and then pull the peg to lower it down, get to it, get access to it. Put the guy wires at the top of the 2-inch, run yourself 6 feet out of the top of it. You know, it's common sense. Schedule 40 pipe only. If you weld galvanize, please use a fan, keep the air moving. Don't weld it and be dangerous. There it is, guys. This is a awesome little turbine. There's a lot of them that look like this turbine. If they don't have that shape in this, and they don't have that same big girth of a PMA, don't buy them. Link for this one will be below the video.